In the lecture on buffer manager, we have seen how data blocks are being transferred from hard disk to the main memory and main memory to block in the form of pages. In this lecture, we will talk about one more level of abstraction of data organization in the name of file. A logically organized collection of records can be thought of as a file. It's again an abstract view of data collection. It is named as a file, and every file may contain several pages. It depends on the Dbms which holds a number of pages in a file, and each file can be partitioned into blocks or pages, of course. The typical size may vary from 4 bytes or 8 bytes, or sometimes user defined sizes can also be defined. So the file organization, once we define a file, the file organization comes into picture, which is actually the how we arrange the records in a file. When we talk about arrangement of records, again we need to understand the nature of the records. Are the records are fixed length all the time? No. Sometimes we may have fixed length of records, and sometimes we may have variable length records. So we need to understand how to store them in an order, and what mechanisms we need to follow so that the retrieval, accessing, and all these things are possible very quickly. In this lecture, we are going to talk about the file organization methods and their processes. In case of fixed length records, the storage and accessing is much easier because the size of the record is already known ahead of storing and retrieving. And if I want to store a particular record of size length n, the kth record can be stored starting from the location of k-1 to n. We can use that. We can easily use that formula and trace where the record is stored. This formula can also be used to retrieve the record very quickly. So insertion of fixed length records is much easier because we know where to start and where to stop. And when it comes to the deletion, actually it's again it poses 3 problems for us, because we don't know which record has to be deleted. There is no sequential order of deletion. Suddenly we may delete one record which is in the middle or somewhere else. So what strategy we need to follow so that next time when we want to insert, once a record is deleted, that vacancy will be created. How to deal with that vacancy? When a new record is to be inserted, where it has to be inserted. So all these problems comes into picture. To deal with this, there are 3 strategies. One is successively move up records is one strategy. That means whenever a record is deleted, successively move up all the sequential records upwards. That is one option. And move last record to the ith location. Suppose if you want to delete one record at ith location, immediately shift the last record to the ith location. That's it. We don't change the other records. This is another option. And the third one is, instead of moving all these records, just maintain a linked list of free records. Starting from the 0th record, whenever a ith record is freed, you assign that starting address of that record, store that record in the first record, or which is freed. So once you start with a first free record, you know where the next free record is available. That's how we can create a linked list of records which are freed, and whenever we want to insert, we can follow that linked list and identify a suitable location to store. So all these strategies are there, which is best, which is better. All these things can be discussed, but it depends on the nature of records and the style in which we want to perform. To understand the storage of variable length records, we need to understand the internal structure of the records, where the records itself stores the attributes, and attributes may not be of same size and same type. So let us spend some time on understanding the internal structure of the variable records, wherein the attributes of different types and different lengths are being stored. Again, the structure of such a variable length record can be understood, which consists of two parts. One is, the first part consists of the metadata, data about the attributes that we are going to store, and followed by fixed length attributes, and then a null bit map, and then the variable length attributes are stored. Here we can consider an example which consists of the metadata consists of the pair of values. One is offset and length of the record. Offset indicates the length in bytes starting from the start of the record, and where actually the corresponding attribute value is stored, and what is the length of the attribute. So that's how we can understand. And initial value indicates the offset, and the next value indicates the length. Once the metadata is stored, then followed by the fixed length attributes are stored of a given length, if at all they exist, and then a null bitmap is stored, which indicates whether a particular location is occupied with a particular attribute value or not. If we devise a mechanisms to store the values in a fixed format, then the null bitmap gives an information whether in the corresponding location the attribute value is stored or not. And then followed by the variable attributes are stored contagiously in accordance with the metadata that we stored at the beginning of the record. That is how the variable length records are created first. Within a file, we observed that it is divided into blocks. Every block is again organized in a fashion similar to the variable length records that we have seen so far in the previous slide. Again, every block is organized. The starting part of the block contains the metadata again, which consists of the number of records entries in that block, and at the end of the free space available, which is information used to store the next records in that block. And an array whose entries contains the location and size, offset and size, just like in the previous case. So that kind of metadata is again stored. After that, a free space availability will be there, if at all it exists, and then the records are stored contagiously. So whenever that block of data is accessed based on the metadata stored at the beginning, we can accurately identify the location of the record, and we can fetch that record if at all if we want to read. So every block is organized in such a fashion in a file. Once we understand the nature of the records, fixed type or variable length type of records, now we need to understand how they are actually stored in a file. When we take a relation is again a collection of records. So for a given relation, how the records are stored in a file. Again, there are various options are there. Each one of them have their own advantages and disadvantages. The first one is a heap type, where the records are stored in anywhere in the file. Whenever there is a free space, just it is stored there, and just a linked list type of connection is established among the records. That's a heap. And the sequential one, stored in a sequential order based on a search key value. Again, based on a specific attribute, key value is taken as a key value. It need not be a primary key. It can be any of the attributes, important attributes. So based on the search key value, they are stored in a sequential order, one after the other, contagiously. Or a multi-table file, where it is stored all related records are stored in one page or one block. And another one is a non-linear structure of B plus tree. The records are organized in the form of a B plus tree, so that accessing and addition and deletion of the records are followed. That B plus tree structure is a graph based structure. And another one is a hashing. The file is divided into buckets, and based on the search key value, a hash function is computed on a particular attribute, and based on the hash function value, it identifies the suitable bucket into which the record is to be placed. Again, these values can be used to retrieve. So all these are all possible ways in which we can organize records of a relation in a file. Each one of them have their own disadvantages and advantages, and whenever a database is created, we can choose our own style to store the files.